Okay. Hello, everyone. Welcome to our embedded panel on dealing with embedded limitations, some of the things that we regularly deal with when we're writing embedded systems. Oh, sorry. I just realized I've messed something up here. There we go. Let's try that. Okay. So welcome again to the our panel on dealing with embedded limitations, dealing with some of the issues that embedded developers often face in terms of restrictions on memory usage, with difficulties using certain C++ features, things like that. I'm Ben Sachs. For those of you who don't know me, my company, Sachs & Associates, does training for companies all over the world in both C and C++. Before this, I worked for about a dozen years as an embedded developer on devices that monitored production line output and gathered statistical information based on that. Okay, why don't we all go around and introduce ourselves? Brett, you want to start off?
Sure. My name is Brett Searles. I work for a company called XKL. That's my main employer, but I'm also have another company called Adobotics. XKL works in optical routers, and Adobotics works in holographics. So some correlation between data there. I've been in embedded for over 20 years, and I'm looking forward to this discussion. I guess we can go to Daniel.
Yeah, I'm Daniel Papke. I work at Collins Aerospace, which is a subsection of Raytheon Technologies. I've worked in embedded area for about 11 years, everything from radios to unmanned systems. And I suppose my interests are mostly in finding ways to do things the best we can given the tools and constraints that we have.
I'm Michael Case, and I've been working in embedded systems for a little over 30 years. Variety of different things, from FDA and FAA certified devices to scientific equipment and consumer products. Deal with bare metal to bare metal with FPGA and other types of boards to things running off the shelf and custom RTOSes. In addition to the contracting and consulting work that we do at Kira for things like this, we also, or I also teach C++, modern C++ classes for embedded systems.
Go ahead, Ingba.
All right, Michael Wong, why don't you?
Okay, I'll go ahead. My name is Michael Wong. I'm a distinguished engineer at CodePlay. We're a company that works in high-performance computing as well as autonomous vehicles. So as such, I've been deeply involved with various forms of programming models, research involving AI and machine learning. And because these days, autonomous vehicles use embedded computing, that is very much like a supercomputer. So that's why I've been involved in things like SG14. I chair SG14 for C++, which has the embedded components in it. SG19 for machine learning. I'm also the chair of the directions group. And because of the AV stuff, I'm also deeply interested in safety critical. Thank you.
Hello, everyone.
Yeah.
Sure. My name is Indal Levy. I used to work on VoIP systems, and I'm currently working on SolarEdge. We're doing smart home management, basically doing inverters for solar energy, but I'm specifically on the field of smart home management. And I'm very excited to be here. I think this is a very important panel, and it also represents the general direction of C++ towards embedded systems. So I'm glad this is happening.
Can we, Ben, are you muted?
Yeah. Sorry, I was having I believe that having both Remo and this open was causing me a little bit of lag. So hopefully that's resolved now. But if not, we will, yeah. It's a new experience for all of us trying to, conducting conferences like this. So we'll deal with it as best we can. Yeah.
We're just like the Brady Bunch. We just got to look at each other.
Yeah. So yeah, Daniel, it was your question on the embedded channel in Slack that originally led us to start talking about the things that motivated this panel. So do you want to start off with just a brief description of some of the things that you were talking about there?
Yeah, absolutely. So while I'm working in the various code bases that our company has, there's lots of challenges that we come across, these additional constraints that we deal with in the embedded area, because we're worried about maybe certification concerns or safety concerns with the products that we make. And so my interests are trying to find the best ways that we can to satisfy the problems and the constraints that we're dealing with, but also make sure we're using the appropriate tools for the area and not just letting ourselves sort of coast along with, the way we've done things before. We want to be continually reevaluating what we have and make sure it's the best that we can get.
Okay, so I think when you talk about the best that we can get, I think you mentioned one of the things on that discussion was that your tools are often rather out of date because they need to be certified, right? That the process requires that you verify the whole tool chain, and once that's done, you only want to change that very rarely, right?
Right.
So now, do you actually have insight into how that certification process works? I haven't. The machines I've done, we didn't have quite that same strict requirement there. So
I suspect that one of the other members might have a little more insight. I just know that the compilers are certified. So, for example, LinkSauce is one that we've used. LinkSauce is the operating system. Links makes the compiler, and that's certified. And it's really expensive because it turns out making a compiler is somewhat difficult.
Sure.
So yeah.
Go ahead.
First, this is pretty standard practice in safety critical systems and aircraft manufacturing, aircraft components is probably one of the safest, the most stringent safety critical, well regulated. I mean, after all, we investigate everything up, and it's for good reasons. And the same thing with automotive that I'm finding, they have to be certified. We call these things safety integrity level. I touched on this in my talk yesterday, that these things have ways of allowing you to deal with the fact that you cannot make everything completely safe and faultless. All we can do is make sure that things that can renders these operations uncontrollable happens very rarely, something like 1 in a million chance. And so we selectively push those items to very high safety levels, like brake systems, autopilot systems, things like that. Whereas other things that are not as important, like maybe the windshield wiper, doesn't have to be pushed to that kind of level. And that SIL level comes with it a whole truckload of things, from the configuration management tools that you need to use, the language of compilers that you need to use, the type of language tools that you need to use. They all have to be certified. And this is one of the things that has to do with embedded when you talk about safety, you have to make sure that if in some cases, either the industry or the standard or the government mandates these kinds of things. So that's why you have to have these kinds of things happen.
And that's why it's expensive
to change. if you want to update your tool, that's a huge recertification, which a lot of companies don't necessarily want to go through, but the governments make them go through it. So it's a way to make us all be safe when we are driving around and traveling in airplanes and things like that, and wearing pace.
So there's a real push and pull here, because sometimes you're being told not to update your tools because we haven't recertified those, but at the same time, sometimes you're being told, no, the new certified version is something else. You need to update to that now.
So, Daniel, do you experience pushback when you're trying to say, let's go to C++ 17, or because of the fact that the costs are pretty high to move to that package? Or are you talking about how do you make your system redundant and exception, proof that we can handle any possible situation?
I think both of those would be considerations. You want to make sure you're respecting the actual real limits you have, and if you have a high assurance level that you're targeting, you may not be able to use all the features of your language, and that's okay. But yes, the compiler is definitely a big limiter in terms of what features you can use. For example, recently I was looking at a project I had just recently joined, and they were using a relatively older compiler for GCC. And I asked why that was, and the answer was, well, some of the other targets that we're compiling for are using something like LinkSauce, for example, and they can't support certain constructs that have become normal. So, you have to use what you're targeted for, and you got to wait.
We sometimes blame these compilers for not keeping up with the C++ standard, but sometimes it's the case that it's expensive and costly for them to recertify to the new standard. So it's definitely a push and pull, like you said.
Well, I can tell you, since I work with a company that owns everything about the PDP-10, that yes, the new compiler code will break the code that is being compiled for the PDP-10. So we can't work. We're working with a compiler like 10 years old, because if we put in something new, it's gonna break. And so that's why we have to invest in the tools, but we just have to invest in the product right now rather than the tools.
Right.
I would like to jump in and say that I actually have a slightly different experience, because we also have to be under certificates regarding electricity and the grid, and but the fact is that we are actually facing a tool chain upgrade, and we're currently in the process of that. And I think there's two main problems here. The first one would be, and I think Daniel actually mentioned that, the first one would be the common knowledge, the common opinion that we don't wanna, we want to avoid things that might end up with errors. And of course, it's probably different with the safety critical topics. But and the other thing is that, I mean, as part of my talk on exceptions, I think is also a very important topic for embedded. I've looked for style guides, and I've seen a style guide of Google suggesting not to use templates because they are too complicated, and that made me feel that we need to identify the real problems and maybe try to advance, because embedded, it's rather ironic, because embedded can gain most out of advanced compilers. So if we'll be able to address that, and C++20, I'll just continue. It's a bit of a different topic, but C++20 is embedded focused. I mean, a lot of the features there are encouraging compile time, and it's really a tool that I would love to have in my embedded systems whenever it will be available.
now connected to that, I have a question from the audience. One of the issues that we sometimes face is not just getting the tools up to date, but also keeping up to date ourselves, especially a lot of people who work on embedded systems. They didn't necessarily set out. Well, some of them didn't even necessarily set out to learn C or C++. They were thinking in terms of being an electrical engineer, and then this was something that also became relevant to their job. Other people, they have a little bit more of a formal training, but it may have been some years ago, or there may be problems because we sometimes worry that educational materials that are suitable for a general audience, there are other factors that we need to take into account in embedded that we don't necessarily, that those other things aren't thinking about. So what would you guys suggest in terms of resources for keeping up to date with new developments in the standard and staying on top of newer techniques that would be suitable for use in embedded systems?
So I found that the collected community of people who's in embedded have been doing their best at putting forward great talks. I'll say that to prepare for my talk on embedded this morning, I watched Michael Case's talk, many of his talks. I watched Odin Holmes's talk. I watched a lot of the other talks by some of the deep experts that I know of that's been in SG14. And Dan Sachs talks, not Ben Sachs, but Ben Sachs talks as well. But I just want to make sure that people know the difference in their names. We talked about that just before. But yeah, I looked at a lot of the talks. So these days, the talks are, I think, probably one of the best way to keep up to date. I hate to say it, but books are almost over in terms of keeping up to date on what's going on. It used to be okay when the standard was like, 5 years, 10 years revisions, and you could have the time to write a book. But it's almost impossible now that I find. Now, obviously, the caveat I'm sure with watching internet stuff, but if you know that it's coming from a respected authorities that know their stuff, you can pretty much believe that 90-95% of this stuff is pretty accurate. And so that's the best way I find. Not to plug my own group, in SG14, we are trying to discuss things that are pushing the envelope. So it's not a great place to learn about what's the latest practice, but it's a great place to learn about where's the latest envelope going. So we're talking about things like how to do exception handling using a stack-based routine as opposed to heap-based routine. That actually, believe it or not, solves a great deal of the determinism problem. And we talk about, new memory allocation routines that are much better, that have lower overhead, like JC-malloc and things like that. And those are new malloc routines that have been floating around out there that have been well tested to show that they have indeed excellent characteristics. JC-malloc isn't the only one. There's JE-malloc isn't the only one. There's TC-malloc. There's Horde. There's a whole bunch of other memory allocation routines that are out there, and we talk about things like we talk about how to push the envelope in that way because that I find that that's pretty much the only way I can do it is to keep up that way. There are books, but they fundamentally are pretty good at talking about things that don't change that quickly. Safety practices, best reliability practices, and things like that.
I would love to answer that as well. I think, and unfortunately, I'm not aware of a good source for that, but I would just suggest to go and research the new features and try to identify if they're suitable in the regular constraints that we're all familiar with. If it's dynamic allocation in your system, if it's compile time, runtime errors. I would just suggest address every feature and try to research in those with this guideline in mind, and that's how you.
Yeah, but that would be next to summarize what all the new features are and how they work in the embedded domain, and give a summary of something like that. That would be a great paper. A lot of people.
Well, I think first we need to identify what is the embedded domain.
Oh, let's not do that yet.
Yeah, that's almost.
That's certainly part of the discussion. We talked about safety critical before, but yeah, continue on.
But I mean, there's plenty of stuff on the internet that you can look at. You just have to look at it really hard, and you're not always going to find the right answer right off the bat. But yeah,
Dan, thank you for not poking the double E too much. Maybe I should have added that to my bio at the beginning, so that, people would be
I wasn't
sensitive.
saying. So just to be clear, one of the interesting things that I remember, I think my dad was saying to me about his experience in this is that if he had a software was building a team to build an embedded device, and he could just hire one person, so hire a double E, they'll get it working. They will be able to connect all of the hardware pieces to all of the software pieces, and they will figure it out. When the code starts getting larger, that's when I'd want to hire some more software-specific guys for that sort of thing.
Or you could hire a double E that does software.
Yeah. Oh, you do that too.
There you go.
You might have been.
On that topic, though, of sources.
Are you selling your company?
I'm not going to sell my company, but one of the things is sometimes the problem is you have to give good motivation on why you would want to do that. Why in the world devote the time and the energy in order to take on all the new language features? It's working just fine for me now. Why would I want to invest in that, right? And so I think there are a variety of different resources out from some of the talks that Michael's mentioned, as well as others that you'll find where motivation is given on why you would want to do that. There are business reasons as well as technical development reasons that most people would recognize as being, this would make my life better to do this in a particular way. I'm going to put a plug in for CPP Ling. Slack has an embedded channel, and I think we're pretty active in there. We're always happy to answer questions about learning and features and things of that sort.
That's great. Just to put people in with some context here, the reason Michael talked about EE versus CS is there's always been this ribbing about how different electrical engineers tend to dive in and start programming right away, whereas CS tends to think and waterfall, agile, and all that. And yes, there's been that, and I talked about it today in my talk as well too. And I'm not trying to rib anyone. I think you're right. You kind of need both, and it would be great if people could be both EEs, electrical engineers, and computer science specialists. But these days you can get. Yeah.
Now, one of the problems that we sometimes have, another question from the audience, has to do with there's some concern about how much of the standard can I actually take advantage of, given that it doesn't a lot of that rely on exception handling and dynamic memory allocation. Is that something that are we able to actually use much of the standard library, or do we really need to focus just on the language features?
So
sorry, I'll stick a quick plug here. That's exactly part of the problem, because there's a certification angle to that too. When you want to certify, you may often have to own the code that you're using because you have to maybe get path or decision coverage. And so trying to figure out how to use third-party libraries of any kind, let alone something that also has exceptions and dynamic memory, is a real challenge. And you really, really hate to have to reinvent or remake something yourself.
So we don't want to make Stepanov sad, right? Like, this much of it is containers and this much of it is algorithms, right?
Right.
And so there are portions of it that obviously are difficult for us to use. We just can't. But there are so many parts of the standard library that are just accessible and usable. And we don't want to ignore those or repeat and remake them again, right? A lot of good work has already been put into that. So I think it's just a kind of filtering.
I would love to add that there's a great proposal called freestanding library, and that's on the way now. And it's by Ben Craig, and he's focusing on identifying the parts of the library that are visible for embedded systems. And I would hope that that would be a step in the right direction to be able to certificate the freestanding parts of the library, and perhaps in that way you will have. And I'm sorry, I'm sure Ben, you're also involved in that, so I haven't. But in any way, I think it's really it's going to be the right step in the right direction, so that
I agree.
You'll be able to have this library certificated once, and I mean for all the users to have.
Well, there's that. It's certainly true that some of this is on the committee's radar. There are active proposals that are working on trying to address some of the questions of right now. Very little of the standard library is guaranteed to be available for embedded systems. But there are proposals to work on changing that. There are proposals to work on making optional certain language features that are of concern to the embedded community. But more broadly, looks like we may have lost someone there. Okay, well, hopefully we'll be able to get Michael back shortly. In any case, there we go. So some of this certainly is on the committee's radar, but I think that to the idea of certifying the library, if I understood something that Daniel was saying earlier, it was that there was this problem of even if it's the standard library isn't necessarily just one library, because there's each vendor's implementation of the standard library, right? And that was one of the problems for certification, if I remember correctly.
I think that's probably definitely true. In general, one project I've worked on, you effectively had to own something if it didn't meet whatever coding standard you were being held to. And you might get some evaluation back that says, yeah, there's all these problems. You had to fix them. So, that's the big thing I think people are worried about, is you want to be responsible for thousands of lines of complicated code that you didn't write. So you end up using something you wrote yourself, or you don't use it at all.
When you say you mean the individual engineer, right?
The company.
This library?
Not the organization.
Sorry, the company or the individuals on the project, you could say.
Okay.
So this is a fairly, hey, Brad, we're back. So this is a fairly common problem in most companies, in that the idea of using off-the-shelf components and that you don't know the back history of, oftentimes it's not permitted. It's called the no soup problem. You cannot be using the software of unknown provenance. This is pretty common. And so if you know about Seinfeld and the soup guy, that's where that comes from. It's called no soup for you. Now, I'm glad Ingval brought up that issue, that Ben Craig's proposal, which is improving the standard for freestanding. And this has been long needed, because the standard still holds to its old definition of freestanding from when it inherited from C. It was a really weak definition. You can only use a few headers and things like that. But these days, embeddeds have vastly expanded to the amount of headers that they can use. And that's what Ben's proposal is heading towards. And like you said, it's a great start. And what we need to do is more after that. What we need to do, and I mentioned it during the talk that most of the standard library, unfortunately, is not usable to the embedded because it requires the heap. And some embedded devices simply don't have a heap. Okay. And so there is a unique pointer which doesn't use the heap. There is intrusive pointer which doesn't use the heap. Okay, there are a few pointers that you could use that is out there, flat map, and a few other ones. I think I talked about that. But so I've always been thinking about this and wondering, is there a way to create some sort of an aspect view of the standard library that doesn't use the heap? This has fundamentally been something that we've been thinking about even at a fairly senior level at C++, is that, the standard library, a lot of people, and it's not just the embedded community, they build different versions of different forms of the standard library for games. Like Electronic Odd have their own versions of it for games. Other people have done the same thing. I started working, and IBM had their own versions as well too. So do other people, and we've always wondered about that. And this is certainly an ongoing debate that we need to resolve, because the library is extremely important in this space. So just remember, no soup for you. Okay.
Yeah, one of the classic concerns that we talked a little bit earlier about, wanting to be able to take advantage of some of the more recent C++ features, but we still also have the issue that some people in the embedded community still prefer to use C. There's this perception that you're going to pay some kind of cost for using C++ over C. And so to what extent do you guys, is that true to your understanding? To what extent does that, is that no longer the case, or maybe never was the case?
Oh, it was definitely the case.
I think that's the way.
Compilers, it was horrible. But compilers, C++, I think it's now a FUD. The C++ compilers now generally will outperform the C compiler if written in really good modern techniques. And that's also fearsome for some embedded engineers. They really don't like the idea that they stuck something in the compiler and what came out wasn't what they expected when they look at the assembly. That's also kind of a cultural thing that needs to be repaired. But I think the idea that somehow there's this baggage that you bring along, there's not necessarily baggage that you bring along. There is if you write bad code, but you can write bad code in any language. So,
yeah, I agree. I would love to. I have an experience of certain company. I was trying to convince a team to move to C++, and what I did, I simply took the code and rewrote the same part of code using C++ that is very thin and using mainly overload resolution, operators, etc., things that are very small bytes that are easy for someone that is not using C++ currently to comprehend. And I've showed that this works. This is more readable, and it works exactly the same regarding performance. So I would suggest that anyone that wants to advance in that direction would do something similar. I think the only way to, we know that benchmarking is the only way to know for sure. And I think that's at least taking the small steps to break your libraries and to move them. That would be good for proving that it's viable. And I think if you do it right, as Michael said, it's just a question of whether you're doing it correctly or not.
Well, I think that Patrice Roy had a good comment, and that was, you can't do everything in one tool. So there are some areas that C excels at that C++ cannot excel at. There's things that C++ excels at that C, you're lost in recreating the tools that C++ has. It wouldn't be worth the time. So like containers, processing, doing searches, things like that, I definitely recommend C++. But for like low-level hardware, you're working with bit management. I have a little difficulty. Maybe I can be convinced.
All right, I got to convince you, Brett. Later, man, you and I.
Okay.
Let's sit at a table.
Okay.
Yeah, if you can find each other.
Or you can message people in remote. So one of the questions that we're getting from the audience, Michael, Michael Wong, I think that this one might be specifically good for you to take a look at. There's this question about, will guidelines discussing moving from C to C++ be integrated into MISRA C++ guidelines for safety and critical or other embedded guidelines? I think that you have some experience working with the MISRA group. Does that? Right. Can you talk a little bit about where the future of that might be going?
Sure. So I think this is referring to this morning's talk where I kind of showed some guidelines about how to move from C to C++, whether you do it in one shot or gradual adoptions and the different rules and all that. I don't really see that moving to MISRA. It's kind of like one of these wisdom things that you gather over time and it evolves. Kind of like what Ingbao is trying to say is, we got all these great new C++ features. We need the time to gather the wisdom to learn how well they work in embedded. Things like that is not going to go to MISRA. MISRA is purely interested in having rules that are statically checkable by an automated checker. So that when you have 1 million lines of code, you can run this checker. It comes out with 1,000 issues that you got to look at. And you can't get out until you look at every single one of those. Either have a deviation record or explain to your boss why you are ignoring that advice. Maybe your answer is, I am much smarter than these guys. They don't know what they're talking about. I don't know what it is. But just be sure, if something happens in a court of law, they're going to look at best practices. And what they're going to say is, well, what is the industry best practice? Well, there is nothing in the standard. Okay, well, what does everyone else do if they're a competent top engineer? Well, they might say, well, we look at MISRA and we look at some of those rules. Rightly or wrongly, I know that I'm not trying to prejudice anything either way, but that's what they did with the unintended acceleration case with the automotive stuff. They looked at the code base that those guys wrote for the braking systems and the electronic throttle control system, and saw that it had never ran through MISRA. It had a psychrometric Mackay complexity of 7, which meant that it was 30 functions embedded within each other. That pretty much equates to hundreds of global variables, all totally unguarded. Okay, so even though they never found a flaw, they considered that a smoking gun, bad enough that in a civil court you will be indicted. Okay, so I'm going to get off my high horse. So metrics guidelines like that, I gathered from the many wiser people than me that are here and around. I don't think they will make it into MISRA. Okay, that's not what MISRA is all about. They might, at best, we could probably do it into a kind of a technical report or something like that. The technical reports rapidly get outdated. The point of an ISO TR is to report the current state of the art on something. Okay.
So this brings up a good point, which is that sometimes the limitations that we're talking about, sometimes they're technical, but at other times they might be legal or have other restrictions in place. Daniel, I know that you talked about in your original question, you had asked about this concern of you'd mentioned some resistance to adopting certain C++ techniques, certain C++ features. Do you have a sense of whether that was more of a technical thing or really more of other concerns?
Well, so you're asking, it's sort of a social problem, right? nobody tells you in college, you're like, you're going to go do computer. And what actually you're going to do is you're going to argue with people for 30 years of your life, right? So you need to be good at the social aspect as well as the technical aspect. And I think there's a little bit of both. On one sense, like sometimes the resistance to features has to do with a legitimate concern of the system, such as determinism, right, for dynamic allocation. And then other times it has to do with, I think, a cultural thing. We haven't typically done things like this. And so we'd like to continue sort of with that inertia. Honestly, I think sometimes, aside from the integral dynamic aspect of it, something like exceptions is like that. People are very used to, in some areas, doing return codes. And so they don't want to change to something different, even though I think exceptions have some really good properties if you can solve the dynamic aspect. So the hard part for me, I guess, is to find ways to convince somebody who's been sort of ingrained with this way of thinking for so long.
Yeah. Well, I think that one of the things that you mentioned was this notion that, well, I don't know what that feature is doing. I don't actually, I don't trust it to be as good as the code I'd write for something along those lines.
So actually, I have a perfect, simple example for that one. I had a conversation at one point with someone. What you do for disallowing the default construction of an object was you'd move it to the protected or usually private area and then define it as, empty or whatever. And so you'd spend, it's 3 lines of code, big deal, right? Well, the big deal was that occasionally you'd see someone move it from the private area to the public, because what they got was a compiler error that said, oh, it's private. And they go, I know how to solve this. And they move it to the public. They didn't understand why it was. So the next thing you do is you make an inheritance of a no copy. And so it says no copy in it, and you public inherit from that. And now it's a little more clear about what you're trying to do. You can't copy me. You can't default construct me. But the simple keyword of delete in C++ 11 is perfect, right? It tells you exactly what you're trying to do. You could ask, why is it deleted? And you get into that conversation. But it's the clearest thing you can say. And you'd get somebody who says, or default, same thing. Both of those, they'd say, how do I know that the compiler is going to do what I want when I have a default constructor? So you go to CppReference.com, you say, okay, here's the list of things that's going to happen when you do a default constructor, or maybe you disassemble it and prove it, but it's like those are all a bunch of work that you have to do to sort of convince somebody.
And I would like to say that C++ is it's better than C for error spotting. For it's a stronger type safe language, and I think maybe this is something that needs to be considered when we're comparing, because it's not just if the code is more complex to reason, but it's also it gives you benefits that of the tooling, and that's something that needs to be known.
I think that's the biggest part, is that in C++, it's easier to develop tooling to check things. And I would definitely propose to your company is that document what you need to find out, or what you need to make sure is safe and critical, and figure out how to tool it on your own. So.
To some degree, though, the compiler is your tooling, right? If you code in a way where you will basically error out if the composition is incorrect, then via composition and it compiled, you actually have a correctly formed program. And there's so much if you do that properly, you can have a lot of confidence right off the bat in things that you can't have confidence of otherwise in C. We got a great tool already, right?
Yeah.
Yeah, if you can use it, right?
Yes.
Well, I mean, yes. I mean, concepts and other things also help with that, with making sure the compiler works according to the way it's designed to manufacture or produce the code that you're writing to work the way it should be.
We have a couple of related questions actually from the audience that, Michael, actually, why don't you read this off, because I have to admit that I'm getting a little bit lost in the text on my screen.
Okay. I think this question is from Honey. It's about, in a typical SAFE, that's an agile framework, when do embedded product engineering teams perform SIL, or safety integrity levels classification? And FMEA, that's failure mode effect analysis, and FTA, which is fault tree analysis, considering longer term projects, including several revamps right up from the arch. Okay, so FMEA and FTA is a well-known a way of connecting failures and cascading failures and understanding how failures can occur. And it's a well-known thing in safety critical systems. If you're in aviation or automotive, you're going to hear a lot about these things. So SIL, I talked about before, is a safety integrity level. So the answer in this case here is that you have to set your safety overall reliable requirements for a system right away, because that's telling you whether, what are the tool chains, what is the configuration analysis and things like that. So even before that, okay, you have to identify the critical components of your system. You look at your system, you see where can it fail. That is a single point of failure. So in a car, you look at it and go, okay, if the steering wheel goes, that's probably a really bad thing. Okay, if your brake stops working, that's probably your two single point of failure. Okay, it doesn't really matter if your window doesn't open. Okay, well maybe it matters if you're in the water or something like that. But and then you go, okay, what is the safety integrity level of those critical components? And because these are basically saying if they fail, death will usually occur. It's pretty easy. They are 3 or 4. Okay. And that means that now you've got to go to do a system breakdown of the failure mode analysis and your FTA, see what kind of failures can lead to these kinds of things, whether it's a single failure or multiple chains of failure or cascading failures. So that's the answer to 1, I believe. 2 is heard from some in automotive that many of the AutoSAR or legacy automotive code is written in lock-free programming style. Okay. So AutoSAR is the other big automotive safety group that is governing all the tool chains for automotive, for the tier 1 automotive like Bosch and people like that. MISRA is mostly started from the UK, although they have spread to the world. AutoSAR is mostly started with BMW, and they're mostly European-based, but they have also spread throughout the world because the supply chain comes from all over the world. And so the question here is asking, do they seem to be writing things in a lock-free programming style? I didn't think they would be. I'm actually surprised by this question because the kind of things they do is actually pretty far from lock-free programming. First of all, you don't necessarily have the right experts to write it well enough. And part of that is because I can only count the number of really true lock-free programming experts in the world on one hand, or maybe 1.5 hands, and I'm not one of them. Okay, so I think it's a hard thing for someone who's in a different domain to be able to manage that. But I could be wrong here. I was in AutoSAR for quite a while, though I've only attended a few of their meetings. So my sense is that they are not necessarily the top lock-free programming experts. Last question, when working on AutoSAR Classic, which is C-based, yes, that's true. Do you think using C++ application layer will make any issue? So that has to do with the fact that AutoSAR, and this confirms the reason why I didn't think they would be using lock-free. The traditional AutoSAR is all basically single-threaded, sequential programming, and it uses C. There is some multi-threaded stuff, but it's not a huge amount. There's a new one called Adaptive AutoSAR, which is for parallel AutoSAR, and that's because some of the automotive chips are now coming out with 2 cores and 3 threads. I know that's a lot for an automotive, but don't forget you're working in a high heat, highly polluted environment. So it just makes everything 100 times worse. I know to us that's nothing. Like we're used to working with 200,000 threads, right? 500,000 CPU. That's what I'm used to working with in high performance computing. But no, I don't think so. Adaptive AutoSort is heading towards C++ in the application layer, and yes, this enables parallelism to some degree, and they're doing it in a very, very slow and deliberate manner to make sure that it's safe. So I think that answers some of the questions. Okay.
So you're saying hyper-threading versus multi-threading, or are you doing multi-threading on the chips? It's
right.
Okay.
Another audience question has to do with one of the issues that is often cited both with dynamic memory management and exception handling is this issue of non-determinism, the idea that we won't know how long a particular operation will take to complete. And there's a question that, are those really the same problem? Is it that the exception handling mechanism is actually relying on memory allocation, and if you could solve that determinism issue, would that solve the whole thing, or is it more complicated than that? Yeah, go ahead.
So, yes, but it's not the whole problem. Dynamic memory is called dynamic memory allocation is being called by exception handling mechanism. So that's one of the problems. And when you do that, obviously you get a bunch of other issues. But there are other problems, and because the exception is allocated through the heap. And because it's allocated through the heap, it has to call dynamic memory. But exception handling has quite a few other problems that you have to deal with. Some of it has to do with that giant jump table that you have to build that makes it difficult to manage. The cost of exception handling is quite a lot. There is the issue with having to create the error or the exception. So in that case, the memory for the exception is allocated in some unspecified way. That's in the standard in accept.throw. That's what it says, unspecified. So it doesn't have to be the heap. It could be the stack. So as a consequence, there's no customization point for this allocation. And there's a lot of implementation that simply just do a heap allocation, even for a single integer. Then the next problem has to do with the error propagation. The standard doesn't mention how this transfer control is achieved. So it does mandate, though, that the destructor has to be invoked for objects along the path from the throw to the handler. This is called stack unwinding. I believe that's in accept.ctol. The next thing is the error recognition part. The exception types are not required to match exactly. They can match a whole class hierarchy. That's another pain point because you have to go through the RTTI to verify that it is part of your hierarchy. So you can have polymorphic catching of exceptions, which then requires determining the types of all the base classes of an object at runtime. So exception class hierarchies are typically complex, and this is one of the few places where multiple inheritance is still common. So there exists, this is obviously a problem. Then the last thing is exception error identification. You have to traverse the type info structure, which is expensive, and the type info structure could be extended and things like that. If you try to extend the type, that's going to make it even more complicated. The runtime analysis is only possible if all the types are known beforehand. If it's not known, then you now have to run through that RTTI table. So the RTTI always brings a non-zero overhead to the binary size. And so the type infrastructure contains more information basically than is really needed to do the matching the catch handler. So so one thing you could do is restrict the matching of the class so that it's always a static type. Some people Andreas Weiss has suggested that because most of the time you don't actually need to have it match multiple possible types. Most of the time, the exception really only needs to match one type. Okay, so there are many solutions. So a lot of that has been discussed through SG14 as well. Yeah. So wait a minute. Our inbounds have a talk on that, I think. So I think you need a better authority.
No, I mean, everything is said. Sorry.
My feeling is that you need to write great code, and you need to understand what's going on. Exceptions are only for cases you can't predict is going to happen, and that's my thought. So
I would just add that I do have a talk about that because I was interested in those questions and of course everything Michael said is yeah, there's a lot going on there, and the stack unwinding process by itself, it not always the same between different compilers. MSVC does it a bit differently, and but I think two things here are interesting, and at least that's what I figured out when I wrote the talk. Is the first thing is that we have more freedom to control that than we think, and I've tried to address how. And the second thing is, and Michael mentioned that I would hope that the standard will address is that we don't really need all the freedom that is described in currently inherited in the exception mechanism, and we could perhaps. I mean, one of the things that needed is ability to. The reason for dynamic allocation is the ability to pass amount of information that is by the developers decision, but I'm not sure we need that. So all those things that Michael said that they could be adjusted, and I would think that that's something that we might want to consider for the following years, and that's. I mean, it's already in the process clearly with Herb's low-cost deterministic. Herb's
deterministic.
Yeah, and the other paper of low-cost deterministic exceptions. So I think we will address that in the future.
Okay. We're coming to the end of our time. One quick question that I want to close with. If I'm new to developing for embedded systems, if I'm not familiar with these limitations, what can I do to get my feet wet? What would we suggest in terms of platforms, devices, things like that would be good starting points to learn more about embedded development?
There are tons of platforms and dev boxes that you can grab. And we'll run out of time, but I'll put some links inside of the chat.
Like a Raspberry, those things are great and they're cheap. I don't know if it strictly counts, but
I think it depends to some degree. This goes back to that question of what is embedded to some degree. Is this notion of I think working on a Raspberry Pi or something like that will get you access to some of the issues that you'd face on a typical embedded device. It's certainly not going. I don't think it's going to be the same experience as if you're trying to get a job with an 8-bit microcontroller team. That they're going to have issues that a Raspberry Pi doesn't. I think that's fair to say. But
I would just love to add shortly that I think the definition of embedded is gonna also might change in the following years because of IoT, because we're going to have a lot more devices that would be considered self-maintained, and I think that'll be interesting as well.
Yes, look for more machine learning, AI types of edge devices now coming to a store near you.
Skynet is coming to you.
Right.
2022.
Okay, so machine learning projects will be one of the ones to watch out for. That's going to be a lot of there's going to be some intersection there, is what you're saying.
Well, yeah, totally. I mean, the Google Tensor Processing Unit hardware is just designed to do convolutions really well, and or vision processing really well. And those are now embedded devices. They have massive processing powers in those things.
Okay, I think that brings us to the end of our time. Thank you, everyone, for being here. Thank you to the audience for all of your questions, for coming and watching us talk, and hope you found it interesting. I think that some of us will be available in Remo to answer questions for at least a little while. Don't want to make any promises for anyone other than me. But yes, thank you for coming and enjoy the rest of CppCon.